When I was young, I always dreaded math class. I usually felt completely lost, and often even humiliated by how bad I was at long division, or quadratic equations, or, worst of all, word problems. What I did love were my English classes reading, writing, even filling out grammar worksheets and diagramming sentences. I remember the thrill of learning to read in elementary school, out of the Sun Up books starring a panda bear and bunny rabbit, the equivalent of the C. Dick and Jane books of the 1990s. I remember falling in love in middle school with Shakespeare and Langston Hughes and Kurt Vonnegut, and I remember secretly typing poems into my TI-83 graphing calculator all through my trig and calculus classes in high school. When I finished my required statistics class in college, I rejoiced. It was the last math class I would ever take. Good riddance, I thought. But now, 10 years later, after I've established my career as a poet and professor of English, I'm starting to think differently about math. It's probably all the time I've spent immersed in the culture of a liberal arts college, where we teach a broad curriculum out of the belief that students should learn a little of all the subjects and find their points of intersection. But this new understanding about math is bigger than just a newfound appreciation for the subject. No, what I've come to understand this year is that math and poetry are really two sides of the same coin. I'm not just talking either about poems about math, of which there are many, or poems that use mathematical principles as organizational tools. Charles O. Hartman's poem Tambourine, for instance, follows formal rules derived from the digits of pi, and Bob Grumman's Math McCoo poems use visual structures from mathematics to create whimsical linguistic playgrounds. I'm also not talking about moments that feel poetic in mathematics, moments like the time I paged through my math colleague's dissertation, all of which was written in math and not English, and found one line of her proof in perfect iambic pentameter and perfect imagistic weirdness. A tower is a column in itself. These kinds of disciplinary intersections are fascinating and beautiful, but I'm actually interested in bigger and deeper connections between poetry and mathematics. I'm interested in the ways that, at their core, poetry and math are both seeking to understand the world through systems of elegant simplicity and radical concision. Mathematics is logic boiled down to its most fundamental parts. Poetry is language boiled down to its most fundamental parts. Both, however, can build into incredibly complex, ornate final forms, with mysterious concepts like imaginary or irrational numbers, or proofs that can demonstrate the universe is a hologram. Poems build and twist and turn the same way proofs do, one step at a time, one line at a time. There's beauty in mathematical logic and logic in poetic beauty. Math and poetry are also both about patterns, studying how they're created and broken and where they appear in nature and in language. I'll narrow down to 3 specific examples for you to show what I mean: equations, asymptotes, and infinity. First, equations. As much as I hated math classes as a kid, I did have a soft spot for algebra, the kind of classic solving for x types of problems. I really liked the balance inherent in equations, that no matter how different each side looked, they were really the same, just disguised. And here's the thing, equations work exactly the same way poetic metaphors do. The whole idea of a metaphor is that you take two things that are totally unalike, that look completely different, and assert that they are the same. In so doing, you come to understand them both better. In other words, when you solve for x in a poem, you end up understanding both sides of the metaphor, the tenor and the vehicle, better. 2x equals 4, to me, is the same thing as saying that hope is a thing with feathers. My second example is asymptotes. An asymptote is a line that a curve approaches as it heads toward infinity. The curve forever approaches the asymptote, getting closer and closer and closer, but never actually touches the line. It's infinity represented with just 2 simple lines. In poetry, the asymptote is the poem you'll never write, the poem you're always striving to write. The poet Jack Gilbert puts it this way: how astonishing it is that language can almost mean, and frightening that it does not quite. No matter how effectively you write a poem, you will never be able to perfectly and completely translate your thoughts and feelings into language. At the end of the day, language always fails. But that doesn't stop us from attempting. And the next poem you write is closer to what you mean, but not quite there. So you write another poem, and it gets closer, approaching the asymptote of truth, but never quite touching it. If that sounds discouraging to you, that's okay, but know that poets find it exciting. My last example of the deep connection between poetry and mathematics is infinity. Only poetry and math really attempt to understand these concepts. Poets and mathematicians alike stand in awe of the infinite, even as we plumb its depths with all the tools at our disposal. One day at work, a mathematician colleague of mine casually mentioned that some infinities are larger than other infinities. I can think of no statement more poetic. For it is only the most talented imagination that could grasp such a concept, an imagination that poets use each time we attempt to express life's most intimate pains and profound joys, using nothing more than language and our own urgent need to express. The disciplines of poetry and math often seem diametrically opposed. People say, I'm an English person, or I'm a math person, like we have to choose camps. But the Jesuit concept of magis asks us to think deeper than these reductive binaries. And so I choose to continue learning more about mathematics and other areas that used to intimidate or confuse me. On my bookshelf right now are Eugenia Chang's The Art of Logic and Beyond Infinity. I'm following my curiosity beyond my comfort zone and stretching myself to new limits. In mathematics, by the way, limits are just a way to think about the infinite. And that kind of paradoxical use of language is just the kind of thing a poet like me can't ever stop thinking about.